Hi guys, let's see how we can answer this question under rotational motion. So we have this horizontal beam supported by these four forces. So the question says find the magnitudes of this force and this force. Now in this question, we've not been given the distance between the forces. So let's just make an assumption. Let's just make an assumption that we can say, let's assume, that the distances or the lengths between each force is equal. Okay, so meaning that the distance from here to here, let's just call it L. From here to here, again, let's call it L. From here to here, let's call it L, because we need it when we'll be summing torque. If that's the case, now let's break down the question. So to start with, let's consider Newton's second law of motion, which says that force is a product of mass and acceleration. So in this case, to start with, we'll just focus on the y-axis. So in the y-axis, because we don't have forces in the x-axis, so we can say force is a product of mass and acceleration. So we're going to sum the forces, and these are forces in the y. So the summation of forces in the y is equal to 0. Because acceleration is 0, this system is not in motion, it's stationary. So how many forces do we have? We have 1, 2, 3, 4. So the forces which are going up will be positive. Hence we have a positive 100 plus a positive F2. The forces going down will be negative. So negative F1, negative 80. Everything is also 0. This becomes F2 minus F1. 100 minus 80 is 20. So if the 20 crosses the cosine, this will be equals to negative 20. Let's call this equation 1. For the sake of reference, we'll come back to it. Now, the next part is we can choose a point of rotation. Now, this point of rotation must be at any point where you have a force. So let's choose our point of rotation to be right here. This is our point of rotation. So at this point of rotation, the torque that will be at this point will be 0, simply because the distance is 0. The distance from this to this is still 0. So at this point, the distance is 0. So we're going to consider torque here clockwise. We're going to consider torque here clockwise and torque here anti-clockwise. Because remember, since it's rotating about this point, then this is clockwise, this is clockwise, this is anti-clockwise. And this is determined by the direction of the forces. Now we know that for this system, the summation of torque is equals to 0. That is what will give us as the net torque. So at this point, we're going to say, what's the distance? Remember, torque is force times a perpendicular distance, of course. So what's the distance at this point? The distance is L multiplied by what's the force? The force is F1. Now remember, it's in this direction, hence we're going to consider a negative. So L distance times F1. Clockwise torque negative, anti-clockwise torque is positive. We come at this point. What's the distance? So we have two L's. From the point of rotation, we have L and L. So if we put them together, the distance is 2L. We are saying negative because it's also clockwise. So distance is 2L from there to here. Then the force is 80. At this point, it's a positive because now it's going in the clockwise direction. So now the distance here is 3L because we have L, L, L from the point of rotation. So 3L. The force at that point is F3. Everything is equal to 0. Okay. So at this point, we can say, let's get rid of these two. Let's push them to the other side of the equation. Or rather, before we do that, let's get rid of L. How do we get rid of L? We're going to divide L throughout. So divide by L, divide by L, divide by L, divide by L. So what do we get? This gives us a negative F1. This gives us the L cancels, so negative 1. This gives us a 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 negative 1. This gi 160. If the 2 multiplies 80, this gives us positive 3F2. Not F3, is F2, sorry. F2. Everything is equals to 0. Okay. So left hand side, we'll have 3, just mark it here. We'll have 3F2 minus F1. This is equals to the 160 can go that side, so it becomes a positive 160. So let's call this equation 2. So we just solve these two equations simultaneously, then we find the values of F1 and F2. So equation 1, we have F2 minus F1 is equals to negative 20. Equation 2, we have 3F2 minus F1 is equals to 160. Okay, so we can eliminate by subtraction. If we subtract here, we'll get a negative, or rather, yeah, negative 2F2. We subtract here, this will be eliminated, come this side. If we subtract these two, we'll get negative 180, like that. So now, from there, we can say negative 2F2 is equals to negative 180. So F2 is simply equals to 90 newtons. So we can find F1 by using any of the two equations. Let's use equation 1. So using equation 1, we know that F2 minus F1 is equals to negative 20. So F2, the 20 can come this side, positive. The F1 goes that side, positive as well. So we'll have F2 is 90 plus 20. This will give us F1. So the value of F1 is simply equals to 110 newtons. So these are the two forces. We have F1 and F2. Thank you very much. This is how we solve this question. In case you have a question, please feel free to drop it in the comments. Have a good day.